learn Linux. Yo! All you need to know is that we have variables. Here we have a total of like 7 variables, which you can see over here. All these variables right here. Conditional statements to do things based on those variables. We also have functions that can do certain things with those variables. We can print out any form of text, or we can print out numbers, or do addition or subtraction, depending on what we want to do. We also have the ASCII table to represent characters using numbers. And we also have arrays, which can be used to store multiple variables or multiple values actually inside of a single variable. Once you understand data structures, your coding life will be on pretty much another plane of existence. You'll be able to do a lot of things with data structures themselves. In the C language, you have to pretty much do everything yourself, compared to like other languages like Python and C#, where there are certain functions to let you do certain things using those functions, basically doing most of the stuff or hard work for you. In C, you have to do all those things by yourself. So, what pretty much I have here is we've created here a pointer with the size of int. You have a pointer over here, so this is your pointer over here. And if you want to access things that are inside of this block right here, for example, all you have to do is pretty much say pointer +1 or pointer +2 to access all these different values inside of our memory. Alright, so what we've created here right now is we have the same base. So we have a pointer with the size of int, and we have 3 values over here. And pretty much what we're saying is that the first value in our array is equal to 5, the second value is 10, and the third one is 15. And what we're doing here is we are showing pretty much the places in memory. So the thing you have to realize or remember is that this num+1 thing is actually the same as this num1 thing that is over here. They are the exact same thing. So to show you this, I'm going to compile this and we're going to run it. So, and there we go. You have all these places in memory. So this one is pointing to this one's pointing to this one's pointing to this. And to prove to you that these are the exact same thing, I'm just going to change these out. So I'm going to just copy this one. So num+1 and num+2. There we go. So you have various data structures. And what you can do is we can actually print out strings using arrays. So what we have here is an example of a string, or actually of a like character called string, and we gave it the size of our character variable, and it has a space allocated to it in terms of like 10 characters basically. And what it should do if we decide to compile this, it should say subscribe. So there we go, it says subscribe. Now bear in mind, what we're doing here is we have a array, and the array has we have like 10 values in our array, just like set by this value right here. And you have to remind that nobody actually sets their strings like this. So we pretty much set str and subscribe. It should work now. It did not complain, so let's see if we can actually run this, and it does the exact same thing. So we have languages like C# and Python. Those are really high-level programming languages. Basically, those languages are used to make our lives easier because they integrate certain functions or certain tools that help us write certain bits of code. You break it down and you go to C, and you learn the C programming language. And then you break it down even further and you go even lower even lower, and what you hit is something called assembly. Assembly can pretty much run on a chip. So, oh yeah, I just realized, in order for you to understand how to work with assembly, you actually have to first learn what hexadecimal is. In total, we have 16 numbers, and what you have to know is that in hexadecimal we count them between 0 and 15, because 0 is used in computers as the first place in memory or in any array, and we're using the number 0 as the very first number. So in order to get to 16, we actually have to go from 0 to 15. So one thing you have to remember is that f, as you can see right here, is actually equal in decimal to 15. And for programmers, it actually makes it easier to look at an f than have to look like at a row of ones, as you can see. If you want to learn more, you can look up binary to hexadecimal if you really want to. What I was trying to go at is that we have like this one program right here that I wrote in assembly. And what this program does is there are like certain registers that assembly uses to do certain functions. So you can think of instructions as functions in a different programming language. And what we have here is we have here a message that is being loaded into a address register called A1. The LEA is an instruction that loads any sort of content, in our case a message, into a data register, address register. So this is where it will be stored in a certain address, in our case A1. Then we move the number 14 into the data register, the 0. Then we display the message. The message will be displayed using the next place in memory, which is 15. Because what we have here is we are pretty much, we're using a carriage return to get ourselves the ASCII code for that carriage return in place of the 0. What we did is we moved the number 14 into the 0, and we then use the 0 to take the information in that place of memory. And what we're doing here is we're moving the number 9 into the 0. Doing here is we then have the message instruction right here, which says just hello world, then it calls the carriage return followed by the line feed, and the line feed is actually what feeds it the data inside, so that will actually enable us to see what's going on. I'm going to execute this, and you can see that it's actually waiting for me to do stuff, so we can I think we should be able to trace over, so we can can keep on pressing it and it will keep on moving, so it will display the message. Then it goes into the next place in memory and it shows the message. You cannot even see it. It's over here, it shows the message. And what you can see over here is all the things that have been happening and all the places in memory. We started at place 8000 and moved to 8006, then 8000A, then back at 8000, back into 8006, back into 8000A, and then into the next place in memory, which is 8000C, and then 8010 to display to hold the simulation so it doesn't close itself, therefore letting us print out this lovely message hello world over here. So there's this question that I'm getting quite a lot actually. It's not like I minded, but like if you guys stopped asking me that, and that is, do I need to know a lot of math if I want to be able to do anything related to computer science? There is obviously some expectation of you to know at least the basics of math. Pretty much all you need to know is addition, because computers use only addition. That's it, that's all they use. Let's say that you want to go even lower. Your next question should be, how does a computer do addition? Because computers do only one thing, and that is addition. And engineers, like really smart people, have pretty much figured out that they can make a adder circuit really fast. you can think of the adder circuit as a be-all and end-all of circuits, basically. On a basic level, how this works, that if you wanna do addition is simple, you just add those two numbers together and you get a set output. You know, you can like do 10 plus 6, it will be 16, that's easy. But how do you do it if you need to do subtraction? Basically, subtraction in our case is, let's say that A is equal to 10 and B is equal to minus 6. In order to do subtraction, you have to do 10 plus minus 6. Then you convert them into their binary, which for 10 is 1010, and for number 6 here is actually 110. Bear in mind we read them from right to left, so it would be like 1, 2, 4, and 8. So it's like 1, 2, and 4, and 2 plus 4 is 6, and we have 2 plus 8, which is 10. So that's how we count them actually. What we need to use is something called the 2's complement. And what 2's complement is you pretty much take all the bits, you flip them. So the 2's complement of this is actually, you know, is 001, because in binary 6 is 110, and we need to convert it into its 2's complement, which is 001, so we flipped all the bits, and then we need to add 1 in order to make it negative, and if we add 1 we will end up with 010. So what we do here is we add those two numbers together. This one is number 10 and this one is effectively minus 6. So what we're doing here is we get a number like this, which it doesn't look like the right number, but what you need to realize is that this in binary represents those two numbers effectively added together, but we cannot really visualize that now. What we need to do is we need to convert it back from 2's complement. So to do that, we take this number and convert it to its 2's complement, which is 001, because we flip all the bits, and then we need to add 1 in order to return it from its negative value. So what we are doing here is we actually add 1, and what will happen is it will move it and we'll get this lovely thing. And this lovely thing converted from binary is you have 1, which is at 0, 2, which is at 0, and 4, which is at 1, which means that the result is 4. So you're looking at this and you're going 10 plus minus 6, it's 4. So you're like, wait a second, and that's when you realize that mathematics is actually far more interesting than you thought. All you really need to know is addition. That's it. There's nothing else you can do. I mentioned the full adder circuit before, so this is where we go actually into the fun stuff. So you have different kinds of adder circuits. We can actually look them up ourselves. So you have a full adder circuit right here. And what you have here is you have two XOR gates, you have two XOR gates, two AND gates, and a single OR gate. And these gates are implemented using transistors. So looking kinda, well, that's not it, but yeah, these gates, all you have to know is these are implemented using transistors, and yeah, that's that. Now, I'm pretty much learning still the transistor level S, but there are some little examples that we can show you in terms of how they function. So I did mention those gates, you know, those circuits are implemented using gates, and those gates have a certain logic to them. And there are like three main types of circuits. You have the AND gate, OR gate, and exclusive or XOR gate. And these gates have their negative forms. So we have the OR gate and we have a NOR gate, which is a negative of that one. We have a AND gate, and a negative to that is a NAND gate. And then we have a exclusive OR gate, and a negative to that will be exclusive NOR. And the way you can pretty much tell which one is negative is by looking at their symbols. So you can see here that the negative OR gate or NOR gate has a little circle over here that's not filled out, and it has a output called F and two inputs, which is pretty much the same for any gate. Each gate has like 2 inputs and 1 output. Most of the time there are different exceptions, but in our case this is like the main thing that we have to look at. So in terms of an AND gate, unless 2 numbers are at their highest point, which is 1 in binary, the output will be at 0 pretty much in any other condition. So unless you have 2 numbers which are at 1 in binary, it won't do anything. This is ideal if you want to make a counter to a certain number. You can make a counter that goes up to 10. Once it hits 10, you put the output of that into the reset switch and will reset the counter and will start from 0 again. So that's how you can pretty much implement this. You can use an AND gate in order to implement a counter up to a certain number. You can make a counter up to 15, or you can make a counter up to 10, or a counter up to 8. All you have to do, well, up to 8 wouldn't really be fun, but all you have to do is take those 2 outputs that you want to get from binary, and you need to put those outputs on the input of the gate, so that once you reach that number, it will trigger the gate and it will release a signal that will be sent onto the reset of that circuit, therefore forcing it to restart its counting. So what am I supposed to, what you, the viewer of my channel, what are you supposed to take from this video? Pretty much, if I can recommend you anything, pick a simple language like Python and start learning structures of like if statements, loops, arrays, functions, and then pick a lower level language like C, and then try to recreate your programs and apps in that. So the one thing you need to know, or that's important here, is once you start with a high level language like Python, get comfortable with it, write a bunch of apps in it, then go lower and go to the C language and recreate all your apps in that. And once you're comfortable with C, try and recreate them in assembly and you should be pretty much good to go. Because every single other language is pretty much derived from C. So yeah, that's pretty much everything. So I hope that this video made some sense to most of you. I spent quite a bit of time preparing for this video, so if it was a bit of a different cup of coffee for you, or it wasn't ideal for you, I'm sorry. But if you found it interesting and want to see some more content related to programming or coding or IoT in general or IT stuff in general, hey, subscribe to this channel, share this video around if you found it interesting. I hope you guys will take something away from this. Make sure to let me know down in the comments if you like this video, because I've been trying to work a lot more on these videos. So yeah, I'm gonna go die now for about 1 to 2 weeks again, and I hope to see all of you beautiful people next time.